Hi, my name is Chia Wenxuan, and then I'm going to start from introduction of R program. Program R, it's a free and open source that we don't have to be a slave to license. Well, because there is another program similar as program R, which named SPSS, but that one we need to pay every single month to for the license. We can also ask global online community for help for any time if we met any problems in R. And also every single error in R, we can Google it to solve it, to find answer to solve it. And while R also will tell us the error in the console, so we can correct it to get away the error. R is evolving and become more stable every day with new packages created for analyzing in different fields. This means like R is keep upgrading to become a better program. Well, we can produce much more publication-worthy graphics from it. R is becoming increasingly compulsory in journals to share R code to ensure the science is reproducible. So, and then R could mean the difference between getting a paper accepted or rejected at the peer review stage. So we can use it at the peer review stage. R. Last, R, it's really cool and can even help us to get a job or scholarship because it is a strength if we know how to use R. So now I'm going to share how to download R program. So it's very easy. You just need to search R program in Google and then click this link. It will automatically download in our computer. So after we download and then you click, it will be like this in here. So export the file into the Excel. So first I need to import the data into here first. I'm going to check the directory. Yes, I'm going to document and I open the script from it, random data set generator. Then we just need to run the whole thing to open it. Yeah, so we can see it here. Our data is here. So before we export this data, I will assign this whole thing as data first. I need to assign it as data. Okay, so to see whether we assign or not, we can view the data. Okay, so all the data is here in the table form. Now we can export it using this one, CSV. Then I name it as the vaccinated patient. CSV. Okay, let me run it. So we can saw it in our document. It's here in Excel. Maybe like this in Excel file. Okay, now back to the R. So we also can see the summary by typing like this, the summary of the data. Then we can get our summary of our data. So here, this is the summary. Okay, so now I'm going to start from the t-test first. So t-test is a statistical test that compares the means of two samples. There are usually two types of it, which are one sample t-test and paired t-test. One sample t-test is for data is normally distributed, while paired t-test is for two data in one set. So before we start for our t-test, we need to check the normality of the data first, of the test first. So to check the normality of it, we can use Shapiro test to check it. And hashtag in R means we make a note of it. So we check the normality of it. Shapiro test. Check the time one, this one, whether is it normal or not, run it. So the p-value shows here is larger than 0.05, which means this data is normal. So I can make a note to say it's normal. Next one. Run it. So this one also the p-value is larger than 0.05, which also normal. Okay, so the p-value also larger than 0.05, which also normal. And then after this, two of them are normal, and then we can go for our t-test. So my search question is the time. We can use the test. mu means the true value of mean. So I'll check whether it is equal to 1. Oh, so the p-value is smaller than 0.05 and the true mean is not equal to 1 for time 1. So, and then I'm going to go for the paired t-test now. So paired t-test, I need to check the normal again because I checked it just now. So my research question is so t so we saw here the p-value is smaller than 0.05 and the true mean difference is not equal to 0. It means there is significantly difference and the null hypothesis is rejected. Yeah. So that means the sample mean is significantly different from the theoretical mean. So now we move on. So there are basically two types of ANOVA. And ANOVA is analysis of variance. It compares means for more than two groups based on the law of total variance, where the observed variance in a particular variable is partitioned into between group and within group variations. So one-way ANOVA is used to compare means for more than two groups and is used when data is organized into several groups based on a single grouping variable, while two-way ANOVA is used to compare the effect for two grouping variables or factors on single response variables. So I'm using the one-way ANOVA. So for this, I also need to check the normality of my before I start my ANOVA test. Time 1. Where is it? Oh, it is normal because the p-value is larger than 0.05. So it's normal. And then I will do subset for my data before I start it. So I do subset for the ethnicity. Subset. Wait, there are 3 ethnicity also. Last one. Oh, wait, I need to run for. So we can. So here, this is for the Malay, Chinese, and Indian. And then I assign it them as subset 1, subset 2, and subset 3. And I select variables of ID, time 1, and ethnicity. So I can copy it. This one. And then I run it. Error. Oh, this one should be a comma. Yeah, and R will tell us the error at here. So we can correct it. Yeah, so now it's assigned. Okay, then I can go for my ANOVA. So before I go for my ANOVA test, I need to do Levin test first to see whether is it. Then it's when I run it, so there's an error again. It should be something typo. Oh, so before we do Levin test, I forget to so we need to call out for the card data first, and then we can run for our Levin test. So the Levin test at the p-value shows that is larger than 0.05. Yeah, it's normal. Then we can run for our ANOVA test. So assign it as result 1. Okay, we do summary for this data. For this, for this result 1. So we can see the summary of it. P-value is larger than 0.05. That's normal. Yeah, so the p-value is larger than 0.05. Thus, the null hypothesis is accepted. So now we're going to move on to the correlation test. So basically, there are two types of it, which mean Pearson correlation and Spearman correlation. Well, correlation means determine how much the two variables covary together. So difference between Pearson correlation and Spearman correlation is that Pearson is more appropriate for measurements taken from an interval scale, while Spearman is more appropriate for measurement taken from ordinary scale. Yeah, so let's start for the correlation test. So my research question for correlation test is, does time 1 and 2 so for this we also need to do Shapiro test before it to make sure that our data is both of them are normal. Then we can go for our correlation test. I'm using the Pearson because this measurement is in the interval scale. Pearson. Let me run it. Oh, I think there's something I never typed for it. Yes, after I run it, we can saw here the COR for it is positive. It's 0.9983147. So the COR is positive, means both these both data, time 1 and time 2, has a strong correlation shapes. Okay. So now we need to continue for the parametric test and non-parametric test. So non-parametric test is non-parametric test is a method of statistical analysis that do not require a distribution to meet the required assumption to be analyzed, while non-parametric test is a method of statistical analysis that do not require a distribution to meet the required assumption to be analyzed, while the parametric test is realized on statistical distribution in data. So their difference is here. And also parametric are those that make assumptions about the parameters of the population distribution from which the sample is drawn. Like two sample tests, t-test and Pearson correlation, they're all parametric tests. But like Kruskal-Wallis test, Mann-Whitney test, Wilcoxon test, and Spearman's test are all non-parametric tests. So now I'm to go for the non-parametric test. So first, the subset assigned subset yes for the allergy for yes. So subset data allergy. And for no, it's for the allergy which are no allergy. Data G equals to no. Okay, I'm gonna run this too. Yeah, it's assigned already. And I'm gonna run for the Wilcoxon test. Time 1 subset no time 1. So the p-value is larger than 0.05, but the true location is not equal to 0. And also Wilcoxon test is compare the medians of two independent groups, but it's not normally distributed. So now we move on to the last part of it, which are plot the graph using ggplot tool to plot graph. So let's move to call out. Okay, and then we plot the graph like using the x-axis is the time 1, and then the y-axis is the time 2. Them in the point graph. So yeah, show the pointed graph of it. Okay, and then we go for the next one. By mapping it with x-axis is the age and y-axis is the time. Then we run it. I think there's an error. Oh, it's time 1. So yeah, forget to type the 1. So yeah, here time 1 with age. Okay, and then we go for another one. Plot the x-axis as the time 1 from data, and then the y-axis is the time 2 from data. Make it a scatter plot. Scatter plot. Y lab is time 2. 19. The famous. Run it. there's another error. I think it should be something typo. I miss. Another typo. Oh, okay. Okay, so we can start here. Scatter plot. Time one is a y x-axis and the time two is a y-axis. Then I can add one line between it, a red line. Theta, theta, one. The theta is theta with in red color. Okay, and run it. Yeah, so there's a red color line here. So that's all for my test. I'm going to make a conclusion for it. So for me, R is really a bit complicated, like compared to Excel, but it is more convenience for us because like we don't need to type every single data like what we do in Excel. You can just like type this all code and just run it. And if like here, if there is any error, and then you like show us, and we just need to correct it, then we can run again. Like we no need to like really do what we do in Excel. Like we need to type every single thing, and if we need to calculate the mean for every single variance, we need to do the same thing for many times. But in R, we can just use a code, and then we can find for everything, and we like the summary for the t-test, and then we can find all the p-value for it. So the R is really more convenience compared to Excel. So thank you.